Alright, so in this video I'm going to be showing you how to apply the concept of impulse and momentum and to solve this problem. So what we have right here is, there's this van that's driving, and what's moving it forward is the frictional driving force acting on the wheels, and that force is determined by right here. Oh, that was bad. 600 t squared. So if the van has a speed of this 20 kilometers per hour, when t is equal to 0, determine its speed when t is equal to 5. So we know the fundamental equation. It says the initial momentum plus the sum of all impulses is equal to the final momentum. All right, so in this case, we're going to be analyzing it only in the x direction. So we're only interested in the forces acting in the x direction. So if we draw a free body diagram of the van, what we have right here is so we have the normal force, the weight, and so it seems like they're neglecting friction. So the only force in the x direction is that driving force, that F sub d. Uh, and that force is 600 t squared newtons. So what we're going to do is, just go ahead and plug what we know into this equation. So what we have right here, mv1, so that means the mass, which is 2.5 megagrams, which is equivalent, we want to convert it to kilograms, which is 2,500 kilograms times its initial velocity. And its initial velocity is right here, that's 20 kilometers per hour, but you want to convert that to the standard units, which is meters per second. So to convert that to meters per second, so we have 20 kilometers per hour. Okay, so 1 hour is 3,600 seconds, and then 1 kilometer is 1,000 meters. So therefore, that speed, you plug that into the calculator, 20 divided by 3,600 times 1,000, which is 5.55 meters per second. So plug that in right here, 5.55 meters per second. Now I'm going to go ahead and delete this so we have some space to work with. Okay, so, and then what we have next is the forces acting in the x direction, the impulse. So the only forces acting in the x direction is the driving force, Fd, which is 600 t squared, and we have to take the integral of that. 600 t squared. Let's say, for example, there was another force in the x direction, like let's say the friction force. Then you would also do plus, and then the friction force. Well, you're gonna actually have a minus here because it's acting in the negative x direction, since we defined to the right being positive. And so that's what you would do, because they're saying that we have right here the sum of all impulses in the direction we're interested in. So anyways, let's continue. So this is with respect to time is equal to, the mass stays the same, 2,500, and then the final velocity, which is what we're trying to figure out. Now you might be asking, what are the bounds here of this integral? Well, we're doing with respect to time. Initially, t is equal to 0, and then finally, t is equal to 5. So let's just go ahead and plug this into the calculator, and that would be, okay, so this value, 13,888.9, and then plus the integral of that would be, take 600 to be the constant, and then over 3 t cubed, simple power rule, and then the bounds, and that would be equal to 2,500 VF. Okay, and then now you also do some plugging in calculator work. 5 cubed times 200, that's 2,500. Actually 25,000. So this is 25,000. You add it to the 13,888. That would be, okay, that would be 3,888. That's 4 eighths. 0.9 equal 2,500 VF. So we divide by 2,500. on both sides, and that would give you the final velocity, which is equal to 15.55 meters per second. And that's it.